Good day and welcome back to a new SoFi tutorial. In this tutorial, you will learn how to set up all the parameters in the SoFi RT panel and in the end, how to successfully launch a SoFi real-time run. Once you have launched SoFi RT from this button, you will get this main panel here. And the very first step consists in defining the input. So the first tab here, this section. Now for this, it's mandatory that the raw data on this laptop or PC where we want to run SoFi RT is fully synchronized with the raw data on the laptop for the acquisition. In my case, I have a folder called SoFi RT files that contains, for the ACSM for example, an ACSM folder where I have the daily raw resolution or the daily raw files, those here for example. Please note that for SoFi Real-Time, it's not strictly required to have the folders always synchronized online, but for ACSM data, it's strictly important that the raw data is in daily resolution. At this point, we refer to the manuals of the manufacturer for Q and TOF ACSM, where to read how to generate the raw data in daily resolution. Well then, let's go back to the SoFi Real-Time panel and discuss how to set up all the parameters. We have two possibilities. Either we define those all manually through the Import Data tab in the orange panel here on the Run from the main SoFi panel, and then in the Real-Time panel under Input and Model, we have to define all the parameters. Or we import a configuration file where the main parameters have been defined in advance. The configuration file, the template of the configuration file, can be downloaded from the repository of Datalistica.com. Good. Let me show you how this configuration file looks like. Let me do this on the configuration file I've already modified for these test runs. It's this here. On top, you have general information for the configuration file. The relevant sections that are supposed to be modified are the four here: paths, names, data type, and model options. The section paths contains all the paths relevant for SoFi Real-Time. Path of executable points to the folder that contains the ME2 exe. Path of input files points to the folder that contains the raw data in daily resolution. In our case, on the desktop, SoFi RT files, we're doing this for ACSM data. Path for scan-wise results, this is the CMB approach. If that is enabled, then SoFi Real-Time performs CMB run on the latest instrument scan and as such guarantees an online real-time characteristic. Path of factor profiles from file, if there is a path here, then this points to an IGOR text file. In this case, it's labeled profiles ACSM at exact that contains some fingerprints that might be used as constraints during SoFi Real-Time. Path of BC data, right now it's empty. If there is a path here, then this points to a folder that contains the BC data, and SoFi Real-Time imports this data, performs source apportionment, and delivers BC traffic and BC wood burning that will be added to the other results of the source apportionment in SoFi Real-Time. Finally, path of external data. This is for the future and will be described in other tutorial as well. Then the section names. Name of HDF result files. This is the prefix of the SoFi Real-Time result file. Name of text result file. This is the prefix of the CMB results. Name of prefix for input file name. This is the prefix of the raw data. This case for ACSM. Name of prefix for BC input file, this is empty. If there was a name here, it will be the prefix of the BC file names. More detail on the tutorial about BC data. Name of prefix for other external data, this is for the future. Then the section data type. In this test run, we're doing SoFi Real-Time on ACSM data, so the data type will be the option AMS UMR /QACSM. We found the MZs 19 and 20. And we want to exclude CO2 related variables like, for example, 17, 18, 28. We only keep 44 during PMF. And the instrument type will be ACSM. To manually define the parameters for SoFi real-time, we start a process in the main SoFi panel. So we go to the import data and we have to import the template, the structure of the PMF input. For that, we simply import the very first scan. So let's go to PMF input data type. Let's go to ITX because we want to do this for ACSM, for example. We choose the file, and in our SoFi real-time files folder, this is the main folder that contains the real-time information in our case, or in my case. Under ACSM, we just pick the very first IGO text file. We import this, then we can close the gray panel, and here we define the information for the PMF input. So data will be the org specs, error will be the org specs error, PR, this is the numerical representation. This is almost for ACSM data. Now, since we don't have a text representation, we have to click no here. SoFi will generate a text information for us. Then we can pick that under PR text. This is an almost text. TS numerical will be ACSM UTC time, for example. And since this is ACSM data and I know in advance that it doesn't contain 19 and 20, we will go for the option AMS UMR QACSM without the 19 and 20. And in addition, we also exclude CO2 related variables for the PMF, so we don't want to run PMF over copies of 44, so we will exclude, for example, 17, 18, 28, etc. Then we move to the pre-treatment tab and initialize the PMF input to generate the effective PMF input template. It's done here. In case you have some fingerprints you want to constrain, you do this from the yellow panel. Now, for the sake of discussion here, I will do this for profiles from the database. So I will go to profiles. X-axis will be from database, from our homepage, and I will pick 3 fingerprints that I know work well for this data set. So we'll take an HOA from Paris, COA from Paris, and BBOA from NG. I will normalize those and extract or import these fingerprints. In case you have external data stored in an agrotext file on your PC, you can obviously do the same from the import panel. Under run, we define then the other options. Here the path of the ME2 exe file. So we go here, in my case, I know on the desktop under C I have the ME2 engine. HDF file, this is then the prefix of the HDF file name. Let's go, for example, with SoFi RT1. Then let's press enter to generate this HDF file. Go back to the real-time panel. Here we also have to define a few things. So first we have to define the path that points to the folder that contains the raw data. This is under input files here. In my case, it's under SoFi RT files and then the ACSM folder. Let's confirm here. Then we'll do this for ACSM. Default is that all instruments are turned off, so we have to click on the red button here to make this green. Now the ACSM is active. The file name here, this is the prefix of the raw data files. So let's quickly check together here. Under ACSM, we want to pass the prefix here. Please note it's all this part here without the underscore, and then those are the daily. This is the daily information. So we want to copy this without the underscore. This is hard coded. So you pass this information to file name. Copy and paste and confirm. Now we have to define the model settings, so the model options. Factor start, factor end are the number of factors. So we have static 4 factors here, with the factor names being HOA, COA, BBOA, OA, classical ACSM factors. Please note the comma separation. Number of iterations here being 3, that is, we do 3 PMF runs. But please note that for a thorough PMF analysis, normally people use 50 repeats. To manually define the parameters, let's open the orange panel. For the sake of discussion here, we go with 4 factors. So we have 4 static factors, starting factor 4, ending factor also 4. We do, for example, 3 repeats. To manually change the factor name, we go under model matrices and then here under factor specs. Default factor names are factor 1, factor 2, 3, and 4. You can just override these names with the proper name. So in the end, it would look like this. Here we have for factor 1 HOA, for factor 2 cooking, factor 3 will be biomass burning, and factor 4 will be OA. A-value constraints, they are enabled. We are constraining some information. And as you can see here, we constrain some fingerprints, so profile, PR contains some information. We don't constrain anything over TS. This voice is empty. We constrain 3 anchors. We have the anchor HOA, we have the anchor COA, and we have the anchor BBOA. Please note, for each anchor we have 3 types of information. We have the first one being the anchor name. The second information is crucial. If this is missing, then the anchor here is supposed to be taken from this local IGO text file here. In case you want to use a fingerprint from our database, let me quickly show it here. Under SoFi from our yellow panel, you have under profiles, if you select for x-axis database, you have access to the currently available fingerprints in our database, those here. Let's say, for example, you want to use HOA from the Paris study as a constraint for HOA. This is the relevant information here. So in the configuration file, apart from HOA, the second information should read, in this case, Paris. Yeah, and then SoFi Real-Time will not check in this local file here, but rather pick HOA Paris from our database. And then the third one is the upper A value. So 0.3 as upper A value here for HOA, for COA, and for BBOA. Now, resampling is enabled, so we perform bootstrap in addition. This can also be disabled. Rolling process is also enabled. We have a growing data set. That's why we are using SoFi Real-Time. So this option is better enabled, but the user can also disable this option. Then you have just the classical window. If it's enabled, we have a rolling window that is defined to be 5 days long, window shift, in this case 1, a daily shift. People normally use a 14 days window width rather than 5 days. The 5 days here are just for the sake of training. To manually define under model matrices, we have to define the seed and the A value. The seed represents the anchor or the initial value for the constraints, whereas the A value represents the restriction. Could be 10%, 20% that we allowed the seed to vary over PMF. For seed and A value definition, I refer to the tutorial how to add an A value constraints where these 2 parameters are thoroughly described. We have to go to the resampling strategy, so the bootstrap here. Here we want to enable that. And then to the rolling mechanism, I want to also enable the rolling mechanism and pass the window width and window shift. For example, 5 days window is fine. 1 day, so we have a daily shift, it's also good. And we want to enable here as well. Also here, please note that people normally use a 14 days window width. Restart RT tells how much time SoFi Real-Time is idle until it restarts the process. So here 0.1 means wait for 0.1 minutes and then restart. Import data and do either CMB or PMF, for example. This 0.1 minute is rather small now and is typically useful if you have pre-tests or if you want to check how well SoFi Real-Time operates. In a real scenario, you typically want to have this, as high as 5 minutes or 10 minutes. The important thing is that this restart RT time is supposed to be smaller than the scan rate of the instrument. Every time you have a new scan, you want that to be processed by SoFi Real-Time, right? So for example, if you have ACSM data with 15 minutes time resolution, you want this to be 10 minutes or 15 minutes, not higher than that. Between PMFs here, we do CMB, so we have a CMB after each scan. So we want to have later results with the CMB mechanism that is then stored in the in the CMB paths here, defined up there. Then statistical tests for the correlation, for the comparison are disabled for the sake of simplicity. In this particular case, we refer to another tutorial where we then describe, how to make good use of these options. To manually define the parameters, you can go to model options here. This is the window length here. The daily shift, this comes from the orange panel. So, we restart the process, default is 1 minute. This is typically the time length of your scan. Between the PMF updates, we want to have, for example, CMB activated. Now, since we have just activated the CMB approach, we have to also go to the Results tab and tell SoFi where to store these CMB scans and how to label these CMB scans. So we have to click on Storing CMB scans. In my case, under the main SoFi RT files folder, I have dedicated a CMB folder that it's supposed to contain then all the CMB scans. So we can just click here and then also pass the prefix for the CMB files. So for example, SoFi_CMB and then press and enter. Please note it's again hard-coded, don't use an underscore here. SoFi will automatically place an underscore afterwards and then the current date. And that's all for the parameters. It only remains to press on Start RTSA evaluation and start the process. That's all for now. Thanks for having watched this tutorial and see you next time.